and get started. So what I have here is I have these playing cards all set up, and I've already gone through and I picked out just the cards that I want to use. So these are effectively our table in SQL Server. Each one of these is a row. I've got a 2 of hearts, I've got a 2 of clubs, and so forth. If I'm going to run a database query against a table, if I'm going to go query that, and I'm going to say, for example, select star from playing cards where denomination equals 2, then yeah, you're right, Lee. This is actually, I kind of think of that as fun too. You all get to peer in on that. I would put my finger inside there, but that's probably a bad idea. So if I wanted to say select star from cards where denomination equals 2, how do I know how many cards I'm going to find inside there? That's what statistics are for. Each statistic is one 8K page worth of metadata about the contents inside the tables. Now, whenever I'm going to go and query that, SQL Server goes, oh, I should probably create some statistics on that column so that I understand what it is that I'm looking for. So let's do that. Let's say that we were going to run this query. One of the things that SQL Server will do is it'll go create stats on each of the things that we're querying about. So for example, let's say that we're going to query by denomination. I can see that we have 4 2s, we have 4 3s, we have 4 4s, 4 5s, 4 6s, 4 7s, 4 8s, 4 9s, and 4 10s. So I've got one of each or 4 of each of these denominations. So now it's time to write our statistics out. So my statistics, my first one is going to be based on denomination. So I'm going to put right up at the top, denomination, and I kind of ran out of space there at the end. So I know that for 2s, I've got 4 of them. 3s, I've got 4 of them. 4s, I've got 4 of them. 5s, I have 4 of them. 6s, I have 4 of them. 7s, I have 4 of them. 8s, I have 4 of them. 9, I have, whoops, I almost said 10 of them. That'd be some corruption there early on. So this is a statistic. This is one 8K page worth of metadata about the stuff that's inside there. So now, if I want to go through and query it, if I want to say, go select star from table where denomination equals 4, for example, I can look at my statistics before my query starts, and I can see that I'm going to have 4 of them. What if, on the other hand, I wanted to query by suit? What if I said, show me all of the cards in here where the suit equals hearts? Well, I don't have anything to tell me what that's going to be like, so I'm going to have to create statistics on that as well. So how many do we have? I would have to sort them into piles, kind of. So I have, when I can kind of cheat here, because I know that we have 2s, 3s, 4s, 5s, 6s, and 10s. All of them, in my case, happen to be perfectly evenly divided. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 of each suit. So I'll go ahead and create another statistic over here on suit. Let's say by suit. And I'll say I have diamonds. I've got 9 of those. Spades, boy, I'm really not good at drawing, and now's going to be our chance to see that. Clubs, this could get ugly fast. And then hearts, I've got 9 of those as well. So if I want to see, go select star from cards where the suit equals hearts, for example, I know that that's going to be 9. Not the DB you're looking for, is like analyzing my poker hand. So statistics are really good for trying to figure out how many results are going to come back whenever you query things. And that would be really awesome if your data never changed. But I'm going to go do, say, for example, an insert. I'm going to go insert a row. And here's the first bummer about statistics. The statistics don't change whenever I do inserts, updates, or deletes. They don't instantly keep pace. Because of course it would suck to constantly go update every statistic that you have every time somebody goes in and does an insert, update, or delete. It would just be too hard. It would take too long. So now let's go run a query again. let's go say, select star from our playing cards where the face equals, where the denomination equals a 2. Well, if I go in and do my estimate based on my statistics over here tell me that I have 4 2s. So I would guess an estimated number of rows equal to 4. But what do I find out when I actually go look at the cards? If I go look at the cards, yes, I have those 4 2s, but someone in here went and added another 2. So my estimates versus actual would be a little bit off here because the statistics have gotten a little bit out of date. Similarly, what if I went over to the cards right now and I said, go select star from my deck where the suit equals hearts? If I went over here to this list, I would say, well, according to this, I have 9 hearts. When in reality, when we go over here, because somebody added that brand new row that's also a heart, thanks, Pete, good to see you. Because somebody added this extra row, bam. Now, Jedi Mind Gorilla, you say something actually awesome here. If you have constraints, then you won't get duplicates of specific kinds of rows. The more that you tell SQL Server about your business rule, the things that are allowed in your database and the things that aren't, the more accurate your statistics can become, because SQL Server can just know that there would never be 2 of hearts. 2 of hearts. Goodness, you can't see me dancing back here because I'm dancing back here. So those are other things like constraints that will tell SQL Server about the data that also influence things like statistics. Yeah. Or as my grandfather would say, even a blind squirrel can get a nut every now and then. Well, let's keep going with that. So we've done one insert, but what happens if we do, say, a few more inserts? What happens if I add a few more rows into my deck there? Now, the more that I add, the more incorrect my estimates versus actual may become. For example, if I now go in and say, show me the number of rows where denomination equals 2, my statistics still say that 4 rows are going to come back from here. Fiker, no. That's a good question, but no. So 4 rows are going to come back from here. Well, let's go in and take a look, and God, that's not so good. So now I am all the way up to like 8 2s. This, not the DBA you're looking for, I know, right? I wish I had an exact identical set. But it's also kind of useful for seeing what the new rows are versus the old rows. If you get a whole lot of activity that happens to be concentrated in one area of the table, now I can run into problems because my stats will be very skewed for that area of the table. But you know what's funny is they're not really skewed for the whole entire table overall. In terms of everybody else's rows, if I went in and queried for, say, show me the number of rows where the denomination equals 3, well, nothing's really changed for the 3s. I still have 4 3s. Santi says, do deletes also have the same impacts? Absolutely. What happens if I now turn around and delete all of the 2s? If I delete all of the 2s, my stats still tell me this. So this becomes an interesting point, is when does SQL Server update this stuff? Well, automatically for the longest time, it would update this stuff whenever about 20% of the rows in the table had been changed. And I'm giving you a really shorthand answer here. What SQL Server does is it counts the number of rows that have been inserted, deleted, or modified over on this, keeps a little track of that, and when enough of them have been changed, it says, okay, timeout. It's been a little while since we've done this here. We should go through and update stats. And it doesn't keep them up to date in real time because it sucks. Updating this in real time would absolutely suck. Let's say that now I've decided it's time for me to redo my statistics on denomination here. I'm going to chuck these old ones because so much of my data has changed, and I'm going to throw that aside. I'm going to chuck this one because so much of my data has changed over time. I'm going to chuck him as well. It's time to write a new one. Let's go denomination. Now let's rebuild our stats again. All right, so I've got 4 3s. I have 4 of those. I have 4 4s, four of those. You don't even want to watch me do this, right? This sucks, going through and reading all of the cards and writing them out. So sometimes what a SQL Server will do as your data size starts to grow is he says, you know what, I'm just going to sample these. I don't have enough time to read through this entire table. So you know what I'm going to do instead is I'm just going to take a quick sampling and I'm going to guess. Let's say that I'm going to look at maybe 10% of the rows inside here. And I'm just going to grab out a random set of 5 cards, let's say. Pick a card, pick any card. That's the first time I've ever been able to say that on a webcast. 1, 2, 3, 4, 5. So let's do sampling with 10% of our data set. And if I sample through 10% of my data set, here's what it looks like. Just by random luck of the draw, I would say for denominations, looks like I've got 1 3, I've got 1 5, I've got 2 9s, and I've got 1 10. But I would go through and extrapolate that out because I also need to guess how many other rows inside here. This table stack is roughly 10 times larger than these cards by itself, so I might say I have 10, 10, 20, and 10. Is that accurate? Not really. But thankfully, SQL servers put a lot of brains into trying to extrapolate what the rest of the stack looks like. Now, when you sample, it's not going to be nearly as accurate as reading through the whole stack, but reading through the whole stack would take such an incredibly long time. George, I knew you'd be proud of me that I actually have the journals and all. I got so many of these back there. Now, it's the same thing with suits. If I turn around and I make my guesses based off of suits here because I sampled the thing, I have hearts, I have 1, spades, let's see if I can draw that out, I have 2, because it's these 2 over here. Then for clubs, let's see here, I got 2 of those as well. And of course, since we said that it's like 10 times more cards, it would look something like this. And there aren't any diamonds in here at all. So that could present a problem to me. If I try to guess how many of my results are going to be diamonds, my estimates versus actual aren't even going to be close. The benefit of sampling with statistics is that it's faster to update those estimates or faster to update those statistics. They're just not nearly as correct as a full scan would be. So in a perfect world, whenever SQL Server does these updates, it would do a full scan. By default, though, when it's creating brand new statistics from scratch, it doesn't want to hold your queries up, so it'll go through and just do quick sampling in order to get a rough guess. This is where you come in. You can do updates of statistics on a regular basis. You can set up agent jobs to go through and process your statistics, to do full scans across these. But whenever you do full scans across these, as you do updates of your statistics, whenever I tear these out and throw them away, that causes SQL Server to build brand new execution plans whenever it touches these. When you update statistics, you're really telling SQL Server, go build a brand new execution plan because the contents of this have changed since the last time that you looked at it. It's up to you to figure out how often you should update these because, of course, there is the cost of updating them. Updating them involves doing a whole lot of reads, but not that much writes. Because we're only writing 1 8K statistic, 1 8K page per stat that we have. We're going to read this whole entire deck of cards. Here's where the real sad trombone kicks in. I'm going to read this whole entire stack of cards for every stat that I have. When I have one stat based on denomination, I'm going to read this whole entire thing, and I'm going to say, well, okay, it looks like I got 3 3s, I got 4 4s, I got 5 5s, I got these 6s, I got these 7s, I got these 8s, got these 9s, I got some 10s, there's a 3 again over there, there's a 10 here, a couple of 9s here. The SQL Server has to do this exact same piece of work, reading through your entire data, putting the data out into cache, or putting your data out into piles so that it can then go count them up and write them down into the denomination. It's going to do, you saw me do all of that there just for the denomination stat. Well, guess what I now have to go do for the suit stat, zoot suit. Now I got to go do that exact same thing for the suit statistics. I got to put all this stuff back into piles. I got to pile it all back up again here, get my table nice and in order. Now I have to read through the whole entire table again, and I have to sort them out by suit. Da, 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 da. This sucks, doesn't it? Even just watching it sucks. You're not even doing the work, you lazy, no good web surfer. You're not even doing the work. And you can see that all this work sucks. Now I got to count up the number in each stack, and then I got to go put in the numbers over here. So it's up to you to strike the balance between how often you update these things, how many stats you keep around, and how accurate of a query plan you need. Because after all, in our beginning, when I said that SQL Server would estimate that, in the beginning when I had the stats told me that I had 4 2s, when in reality I actually had 5 of them. How much does that actually matter? Not that big of a deal, unless you're joining this to a billion row table. If you're joining this to a billion row table and you have 25% more stuff than what you expected, you're probably in for a bad time. And of course, in the real world, when you do this, you're talking about 100 million rows, billion row tables. Fortunately, SQL Server even takes the size of the table into account. As your data size grows, he starts updating these statistics more often. He starts using lower and lower thresholds because he knows that the stats really have to be up to date as your data size grows. Now, that, I have the mechanical one. It's in the closet, but it's the old Keychron. I haven't got the new one yet. So that is everything that I wanted to explain to y'all via hand. Now we're going to switch in and go take a look at it in SQL Server Management Studio, and we'll see how this exact stuff plays in. First, I'm going to give a quick shout out to this week's sponsor. So this week's sponsor is Quest Database Training Days. Quest is doing a brand new series of webcasts with me, Penal, Janice Griffin, and we're talking about all kinds of stuff, index tuning, statistics, performance tuning. So you can go register for that over at brentozar.com/go/database days. And right now, you can go up there and watch the past webcasts. There are also upcoming webcasts that haven't been announced yet. If you go and sign up for those over there, you'll get alerted whenever the brand new one comes in. Mom says, let's just play Uno. It's funny, I worked on that deck for so long, and worked on that session, what I just did there for so long, and I was so excited that I've been trying to use these for years, those SQL Server playing cards. All right, so now let's switch over and take a look at SQL Server Management Studio. All right, so now let's go run queries, and let's see how this stuff affects way over in real life. Mesut says, where can we get one of those playing cards? Unfortunately, I don't think Microsoft has been giving those out for years. So what I'm going to do is I'm going to start by creating a table called playing cards. And I'm going to go load it up. Our dealer. Oh, that's good. That's pretty good. I'm going to put in a table full of playing cards so you can get denomination and suit here. I've loaded it up just like a real playing card deck where we have 4 of each number. So 4 2s, 4 3s, just like what we were seeing here a second ago. Then 1 of each suit. Now, I'm not going to take open questions yet. I'll do questions whenever I'm done with the demo, but let me work you through the demo first so you can see some of the challenges with this. So I've got through here from 2 all the way up to 10, and each one of them has exactly 4, one for each suit. Now, if I go to run queries against it and I say I want to go find all of the cards with one given suit, to do that, I'm going to need indexes. So what I've done is I've created indexes on the denomination and indexes on the suit, but these are just one column indexes. When I create one column indexes, I also get one column stats, just like the ones you saw me create a second ago by hand. SQL Server automatically creates a statistic with exactly the same name. This helps me when SQL Server needs to estimate how many rows are going to come back from my results. If I look at the statistics, here's how they look inside SQL Server. I've run the command called dbcc show statistics, which will show me the contents of my stats. And SQL Server stats look ever so slightly different from mine. SQL Server stats are broken up into buckets, and you notice it looks like SQL Server only did the even numbers. But SQL Server's freaking brilliant. It is so smart. What he's saying is, in the bucket for cards with 2s on them, there are exactly 4 rows equal to with the denomination equal 2. Now, in the bucket between 2 and 4, that's what this row is right here, there are exactly 4 rows equal to 4, but there are also 4 other rows in this range. What range? Well, the range between 2 and 4. I suck pretty bad at math, and it's sad to say that with my mom and Facebook watching me as well. But Mom, you taught me how to read. You never taught me how to do math very well. So even though I suck really badly at math, there's only one number in the range between 2 and 4, and that number is 3. So even though doesn't look like there's a statistic bucket just for 3, there actually is, because it's obvious that there's only going to be the 3s there. Same thing with this bucket. In the bucket between 4 and 6, greater than 4 and less than or equal to 6, there are exactly 4 cards with a face of 6, and there are 4 cards in between the 4 and the 6, which means the 5s. It's really cool. He does the same thing for suits. If I turn around and say, show me the stats by suit, here it's a little bit different. We're not even getting ranges inside here. SQL Server just said there are exactly 4 rows inside here, or exactly 4 suits inside of here. Each one of them has exactly 9 cards in it. SQL Server then uses these statistics whenever it has to estimate the number of rows that are going to come back from your query. So for example, if I say, go get me all of the rows where denomination equals 2. So here are our 4 cards where the denomination equals 2. What's the execution plan look like? Now, in the execution plans, very often in my performance tuning classes, I talk about how you want to look for variances between estimated and actual. When estimated and actual are really far apart, your performance is probably going to suck because SQL Server didn't allocate the right operations for the workload that you're trying to attempt. If I hover my mouse over that table scan and I look at the estimated number of rows is 4. Actual number of rows is 4. That's fantastic. SQL Server used its statistics on the denomination in order to figure that out. SQL Server will even tell you in newer versions of SQL Server, if you right-click on the select and go into properties, there's this little thing over here that says optimizer stats usage. SQL Server saying, hey, well, yeah, it turns out that in order to estimate that, I always use a guy's voice for SQL Server because he's dumb and stubborn and he refuses to ask directions. He's all, trust me, I got this, when he doesn't usually got this. He says, okay, I use the playing cards table. There's a statistic on it for denomination. That stat has 100% sampling, so I'm super confident in the results that I'm about to achieve. And that's the stat that he used in order to estimate that 4 rows are going to come back. So far, so good. Let's drill in and ask something just a little bit different, though. Let's go ask him how many cards have a denomination of 2 and a suit of hearts. 2 of hearts, two hearts that beat as. Oh, wait, hold on a second here. Jackson Turner says. So now, if here he says one row came back out of an estimated 2, that's what that 1 of 2 means. One row came back out of an estimated 2. If I hover my mouse over here, see how it says estimated number of rows per execution 2? Well, where did that come from? Well, it's not super accurate. So part of the problem that we're dealing with here is that SQL Server only has statistics on one column right now. Yeah, Santi, that's okay. That's a separate thing. We're just talking about statistics for now. So in here, the statistic on denomination is only on denomination. It only knows that for any given 2, there are 4 rows that are equal to 2. But that's all he knows. He only knows that there are 4 rows equal to 2. Then if I turn around and look by suit, SQL Server says, well, round about 25% of the data matches up with each heart, or with each suit. He knows that roughly 25% of our data are spades, 25% are clubs, 25% are hearts, 25% are diamonds, and so forth. But it doesn't get him all the way to the point of saying for 2 of hearts exactly how many rows are going to match, or even roughly how many rows are going to match. His estimate wasn't terrible, mind you, but we could do better. In order to do better, let's create indexes on both columns. Before, when we created indexes, we only created an index on denomination and one on suit. Here, I'm going way wild and crazy with the indexes. I'm saying go create an index on denomination, comma, suit, and an index on suit, comma, denomination. Now I'm going to look at the stats on this index here in a second, but before I do, let me remind you of what the stats looked like just on denomination. When I had stats just on denomination, here's what SQL Server was saying. He knew rough stats about the number of rows that were matching for any given denomination. Now let me scroll down and take a look at the stats on our new index on denomination in suit. And now SQL Server knows a little bit better about each component of, for any given combo of a suit and a denomination, it's starting to guess what percentage of them are going to match. But the only thing that changed inside these stats was that line right there. These lists of buckets did not change. I don't want you to think that SQL Server knows that there's 2 of hearts has exactly one matching row. He does not. In terms of his stats by individual denomination, he just still knows that there are 4 2s, 4 3s, 4 4s, and so forth. He doesn't know with confidence that there is 1 2 of hearts. At first, it's going to look like he does. If I go in and query for that, if I say, go show me all of the cards that are 2 of hearts, and I go look at the execution plan, this looks amazing. SQL Server says, oh, I estimated number of rows. It's actually 1. It's just 1 now. It's not 2. I know better. I've learned. Went to college. Actual rows that came back 1, estimated number of rows 1. So far, so good. Not bad at all. What happens when I start doing things like loading data in? What happens if I insert another row with 2 of hearts, just like I did in my overhead demo? If I add another one, the first problem, is if I go and run it, it shows that I have 2 rows, but if I hover my mouse over the execution plan, look at that estimated number of rows there. It still says 1. And if I hover my mouse over it for the details, it's ever so slightly off. It says 1.02778 now, but it's not like it's really accurately guessing that 2 rows are going to come back. Well, this is just like my handheld demo. Whenever I inserted one additional row, it's not like it updated my statistics. As you load data, SQL Server knows that the data is changing, but it's not like it has statistics kept up to the second. And in fact, if I go look at his statistics, what the stats say. At the time that stats were, you like that? I like that. That's as soon as I wrote the comment, what do the stats say? I had immediately delete the do. And you'll be singing that all day long. Between two of hearts and what the fox say, you'll be in good shape. So there were 36 rows at the time our stats were updated, but that has changed. Now there are 37 cards in the deck, but SQL Server isn't tracking those minute details. If I want to get all the exact stats up to the moment as of that brand new row that I just added, I'm going to have to update my stats again. Let's go update the statistics, and I'm going to do it with full scan rather than sampling. I just want to make it clear that SQL Server's reading the whole entire deck and updating his statistics. Now, when I look at denomination by suit, now SQL Server knows there are 37 rows, which sounds good. But now look down at the bottom. So down here it says, in row number 1, it says, how many cards do I have that are 2s? SQL Server just knows that there are 5 2s. He doesn't know what the suits are. SQL Server doesn't have a way of knowing that you have 2 2s of hearts. And if I go in and query that, if I say, all right, SQL Server, now go show me how many 2s of hearts that I have. If I go look at that execution plan, remember before he was estimating 1. And at first, it looks like it's still 1, which would suck. But it's not that bad. It's kind of bad. If you hover your mouse over it, look at estimated number of rows, it's gone up fractionally. SQL Server knows that there are 5 2s. He's just not sure what suits they are. He knows that overall, roughly the percentage breaks down as 25% per suit, but he just has no way of knowing what the extra 2 is. So he throws a little bit extra in here into the estimate in order to play it safe. Frankly, that's awesome. I'm just amazed that this even works as well as it does. But a lot of people are surprised that SQL Server, even after a full statistics update, doesn't know that there are 2 2s of hearts. That's because the statistics are really only on one column at a time down in the histogram. You do get a little bit extra up here telling you roughly how many there are overall per denomination and per suit combo, but it doesn't tell you that it's skewed on a per row basis down here. Similarly, if I go through and I update an entire row, let's come down here and say, or update all of them. So if I say, update the playing card, set suit equals heart, where denomination equals 2, now all of them are hearts. Every single one of them, all 5 of my 2s are all 2 of hearts. So if I go in and ask for it, if I ask SQL Server, hey, what's going on? How many 2s of hearts do I have? And I look at the execution plan, I have 5 of them. But if I look at the execution plan, SQL Server still estimates that only 1.35 rows have that. The challenge, of course, there with what just happened was I ran an update, but the stats haven't caught up yet. Same problem happens in real life. When you update an area of the table, that stats on that area are going to become increasingly out of date. The fix, if you need to fix it, is go through and update your statistics. I'll update them with full scan. What the fox say? Over here now, my stats tell me that for 2s, I have 5 of them, but that's all it says. It just says that I have 5 2s. It doesn't tell me that they're all hearts. Over here, my density vector has changed a little. It is telling me that things are a little bit out of whack for some of the suits, but it doesn't tell me which denomination and which suit are my outliers. So when I run this query again, telling me how many 2 of hearts I actually have, it's not like it's really accurate. It's vaguely accurate, it's just not really accurate. So here I have 5 rows that are all 2s of hearts. And if I look at how many rows SQL Server expected, it's up a little, but it's not up enough that if you needed razor sharp accuracy, you would really be able to handle outliers here. Now, I have been going through over the course of the last hour and giving your half hour, I've given you an overview of how stats work. The idea being, I just want to open your mind to some of the challenges that we run into when we're trying to estimate numbers of rows. And I've got a set of takeaways down here at the end. So for example, stats aren't indexes. They only contain limited metadata. They help SQL Server guess how many rows are going to come back, but they're nowhere near exact accurate. Normally, they don't have to be. Normally, your data is pretty evenly distributed. It's just that whenever you have outliers, it doesn't matter if you're updating your stats constantly. Certain combinations of outliers are going to start giving you problems. If you want to learn more about it, a few years back, Doug Lane recorded an entire video class about statistics, and it's all for free out on our YouTube channel. So you can go watch hours of videos just about SQL Server statistics over at brentozar.com/go/learn-stats, where he gets into more details about things like SQL Server's cardinality estimator, multi-column statistics, multi-column filters, and much more. All right, and that is thanks to this week's sponsor, Quest. So Quest sponsored us to do a series of free webcasts called Quest Database Days. You can go register for those and watch them over at brentozar.com/go/database days. All right, now we'll go through and do some open questions. So let's see here. Sukhvir says, do adaptive memory grants help in outliers? I have a whole separate class just on adaptive memory grants and how they backfire so bad. It's actually the one feature of SQL Server 2019 that I immediately turn off. Pratik says, since SQL Server now knows that there are 5 2 of hearts, can't it just use that stat? What makes you think it knows that? It doesn't know that. That's the whole entire problem. When I run it, if I go hit execute on this and I see that there are 5 2s of hearts, results don't get written back into the database. It's not like SQL Server persists query results and says, oh, next time things will be different. It's not like you and all your exes, every relationship that you've had, you've learned from it, you've grown. You would never make the same mistakes again, would you? Because you now have learned your bad behaviors and you won't ever repeat them again. Oh, that's right, you haven't learned. You're still in the same bad relationships. I feel you. I struggled with that for a really long time, too. SQL Server is still in that phase where he's trying to figure things out and do better on his relationships. Not the DBA you're looking for says, what happens to the stats if you added an extra odd number? You can go through and see. That's the beauty of demos like this. You can go through and repeat the same kind of thing inside your own and watch to see how stats change over time. You can insert a row. If it's just one outlier, SQL Server is not going to pick it up until the next time, of course, that it updates statistics. And when it updates statistics, it should show up in the statistics histogram. I am very happy with that. I think that demo went really well. I don't even know that I need to change anything about that. Every now and then, even a blind squirrel can get a nut, right? That's what we talked about there. Contact says, if we inserted 2 nulls, will it bring the estimate closer to actual? What? You're saying if we insert fake data, will we get better query results? Are you a developer? You're gonna put fake data in to get more? Are you out of your mind? Would you try that at work? Would you say, hey boss, I'm gonna insert some fake sales and so that our query results can be more accurate? What do you work for, Enron? They're closed now. They got caught doing that kind of thing. They screwed it up. Mossy Moss says this demo was awesome. Thanks. Glad y'all liked it. I had a whole lot of fun. I've wanted to do this exact demo for literally years. I've been having it in the back of my mind, just literally how I was going to do it. Mr. P. Shaw says, how Caroline says that was great, except I expected some cooking to commence. This is how I loaded the data. So I did an insert into the playing cards table, and I used a list of values cross-joined to a list of suits. So that worked pretty well. Sukhveer says, what difference between actual and estimates would you consider a problem? For me, the starting point is 10x. If they're either 10x too high or 10x too low, I'm probably going to have performance problems. In my mastering classes, though, I even show you examples of where SQL Server's estimates are exactly correct, but it doesn't understand the contents of those rows, and that's where it runs into problems. Dixie asks, how does the estimator estimate how many rows will be returned from a join operator? That's way beyond what I can explain here quickly. So we do get into that in my mastering index tuning classes. Yeah, a couple of good questions go in there. Brendan says, Brent, you get up too early. I've been up since 2 o'clock. So, all right. Well, thanks, y'all, for hanging out with me. And then I'm actually going to do that exact same demo tomorrow because the people who regularly watch my streams on the weekends, I've been telling them about this demo for a while. So I've been prepping them about it. But now I have my whole camera set up above me. I'm going to have to move this out of the way because I have a conference call starting in about, I don't know, 3-4 hours. But then after that, I'll put this back where it was. I would really love to, Santa says, could you put the link for the Quest training please up? Yes, absolutely. So that is brentozar.com/go/database days. And yes, my work really is that, or my desk really is that clean. Dieter, you already saw the demo. What the hell you want to know what time tomorrow? You already saw it. You saw it. It was it. You saw it. What do you want to come back in for? You don't like me. I'm not that cool. I'm all right. But it's usually, I do 6 a.m. Pacific. So 6 a.m. Pacific. All right. Well, thanks everybody for hanging out with me. Bye. I guess I was waving to the wrong camera. Bye. And I will see y'all later. Adios.